Hello, class. This is Mrs. Gregorio, and welcome to another edition of California Math. Today we are covering Chapter 1, Lesson 5 on how to graph proportional relationships. Please follow along with me on page 45, and remember to pause or write down any questions you might have during the lesson. You can view this video unlimited amount of times, so please watch it again if you have any questions. To start with lesson 1, I'd like you to open up your books and study page 45. There are a lot of vocabulary words for this section, so I'd like to go over a few of them with you. If you notice, you see a graph here. This is called a coordinate plane. And the coordinate plane is what we will be using this chapter to identify if a relationship is proportional or not proportional. In order to understand the coordinate plane, you need to recognize that it has 4 sections called quadrants. Quadrant 1 is in the upper right-hand corner. Quadrant 2 is in the upper left. Quadrant 3 is in the lower left corner. Quadrant 4 is in the lower right corner. So those are your 4 quadrants. You'll notice we also have these 2 lines. The horizontal line is called the x-axis. The vertical line you see is called the y-axis, and I'm highlighting this for you so you can help identify the important parts of the coordinate plane. Within the coordinate plane, you also have something called the origin, and the origin is in the very center. We call this point 0, 0, and I will highlight it in blue here. This is the origin. Okay. And in order to identify how to label the parts of the graph, I'm going to teach you how to find an ordered pair and graph it. An ordered pair looks like this in the blue. You have parentheses 1, 2. The 1 is your x coordinate. The number 2 here represents your y coordinate. So if you look at the graph, I will graph it here with you. You go over 1 space to the right. That's your x-axis. So this is your x point here. And then you're going to go up 2 spaces on the vertical y-axis. So it's over 1, up 2. When you get to the point where those 2 lines intersect, you can plot your ordered pair. And I like to label my ordered pairs as I plot them. This is point 1, 2. Continue to read through those examples on page 45. And I'd like you to try to graph points 2, 3. And the other one I'd like you to try is -3, -2. Okay, just so you know, the right-hand side is the positive, left-hand side is negative. The upper half is positive and the lower half is negative. Go ahead and try to graph these ordered pairs, and we'll check it tomorrow in class. Pause the video now and try plotting those points. Okay, continuing on with example 1 on page 46. This example will teach us how to identify proportional relationships. Another way to determine whether 2 quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the 2 quantities is a straight line and it passes through the origin, then the 2 quantities are proportional. So looking at example 1, it reads, the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. Explain your reasoning. So to begin, we need to start by making a table to find the number of feet walked for 0 minutes, 1 minute, 2 minutes, 3 minutes, and 4 minutes. So I'm going to go ahead and fill in the table that you see here. Fill it out with me, please. So the time is 0, 1, 2, 3, and I'm going to add another column for 4. Okay, and the time is in minutes. So at 0 minutes, how far can the sloth travel? Well, since 0 minutes represents no amount of time, sorry about that, 0 minutes would be 0 distance. And the distance is measured in feet. So I'm going to fill that out with 0. In 1 minute, it can travel 6 feet. In 2 minutes, it can travel 12 feet. 3 minutes would be 18 feet, and 4 minutes would be 24 feet. You'll notice that it's increasing here by 6 every single time, so we're looking at multiples of 6. Now, we need to go to the graph and try graphing the ordered pairs. Now, to understand the ordered pairs, let's call time our x-axis. And I like to label the graph that you see with the x. And let's call distance our y-axis, which would be the vertical line here on the graph. Okay, the points that you see here can be written as an ordered pair, 0, 0, 1, 6, 2, 12, and 3, 18. So I'm going to label the graph that you see by numbering the time in minutes. So at this point, you would have 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, and so on. On the left-hand side, to make it easier, I'm going to label it in feet, and I'm going to go in multiples of 6. So I'm going to count this one: 6, 12, 18, 24. You can decide how you want to label your graph if you want to do this on a piece of graph paper. If you're looking at your books, the graph is already labeled for you. So now it comes time to label and point the ordered pairs. 0, 0 is found at the point which we call the origin. So I'm going to put my green dot there. The point 1, 6 means you go over 1 on the x-axis and you go up to 6 on the y-axis. Please put another plot there. The point 2, 12 is over 2, up 12. Plot your point. The next one would be 3, 18, so go over 3 up to 18. There it is on the graph. And my last point, which I forgot to write as an ordered pair, I'll show you over here. 4, 24. Go to the number 4 on the x-axis and go up to number 24. Then you have your points plotted. Now I'm going to use a line here to show you how the graph would look if you connect the lines. If you have a ruler, it's a great idea to use a ruler when you do this. Every point needs to touch the line, and there you have your graph. Notice how the line touches the origin. Whenever you have a graph that hits this origin at point 0, 0, you have a proportional relationship. So since we need to explain our reasoning, I will say that because, I'm going to write this out, because the graph passes through the origin, and the origin is point 0, 0, it is proportional. You can also double check the proportionality by writing the relationship time and distance as a fraction. So you can write this as 1 over 6. 2 over 12 reduces to 1 over 6. 3 over 18 reduces to 1 over 6. 4 over 24 reduces to 1 over 6. So you can see that for every 1 minute, the sloth can travel 6 feet. Please go ahead and try activity A on the bottom of page 46. Pause the video now to work out example A. Okay, example 2 on page 47. It says the cost of renting video games from Games Incorporated is shown in the table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane. Explain your reasoning. So here they give us a table, and the table represents the video game rental rates. One game costs $3. Two games is $5. Three games cost $7. And 4 games cost $9. For step 1, we need to write the two quantities, which are games and the cost. We need to write those as ordered pairs. So let's let the number of games be our x coordinate. So I'm going to call this x. And let's let the cost represent our y coordinate. So we'll call that y. So to write the first one as an ordered pair, we have 1, 3. The first point being the x and the 3 being the y. The second point we have is 2, 5. 3, 7 is next, and last is 4, 9. So now we can take the ordered pairs and we can go ahead and label them on our graph. Now I'm going to label the points before I graph them so I know exactly where to plot the points. I'm just going to increase by 1 on the x-axis. Okay, and I'm going to do the same thing on the y-axis. Let me bring that down a little bit. There we go. So this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, and 10 is at the very top. Okay, so now to label and plot our ordered pairs. We want to start with this first one, 1, 3. 1 would be 1 over on the x, and 3 means you go up 3, so we'll plot our first point where those two lines intersect. Please make sure you put them where the lines cross. Do not put a point in the open space. The next point is 2, 5, so we go over 2 up to 5 and put another plot there. Third is 3 games, cost $7, so we put our point there. And last 4 games cost $9. So now if you have a ruler, please use your ruler and graph the points. I'm going to use my line here, and I'm going to show you how the line, let's make sure it lines up correctly. We want to make our line as straight as possible with all points touching. Okay, that's pretty close. Not exact, but pretty close. Now, in order to determine if this is proportional, we need to check the origin. Remember, the origin is where the x and y axis meet. Okay, it's the cross here. Let's just go only on the origin right there. You need to test to see if the line touches the origin or if it passes through this point. Since the graph is above the origin, it does not pass through 0, 0. Therefore, it's not a proportional relationship. So I'm going to explain here. Since the graph does not pass through the origin, it is not proportional. And another way to check is to show the relationship as a fraction. This is 1 over 3, 2 over 5, 3 over 7, and 4 over 9. Since none of these fractions can be reduced, you'll notice that it is not proportional. They all have different fractions. They're not the same. I'd like you to try activity B on the bottom of page 47 at this time. Go ahead and pause the video now and work that out. Be prepared to share your answer with a partner in class tomorrow. Okay, our last example is example 3 on page 48. Our question asks, which batting cage represents a proportional relationship between the number of pitches thrown and the cost? So here they give us a graph. The y-axis, let me go ahead and label that for you. The vertical axis is our y, and y represents the cost in dollars. Our x-axis represents the number of pitches. Now, looking at the two lines, our red line is called Fun Center. And I'm going to take some notes here. I would like you to write this down either in your work zone or off to the side to show your thinking. Fun Center has 4 pitches, and for 4 pitches, it cost $1. For 8 pitches, it cost $2. And if you notice, here, let's scroll this down a little bit. It touches the point 0, 0. So that means 0 pitches will cost $0. That sounds fair. If you're not pitching, you shouldn't have to pay, right? Well, now let's compare it to Softball Plus. Okay. For Softball Plus, you see the blue line in our table or in our graph, and you will notice that it actually starts not at 0, 0, but it starts at 0, 3. So that means for 0 pitches, you have to pay $3 just to enter into Softball Plus. At, it looks like $6 or 6 pitches here, you have to pay $4. So for $1 more, you get 6 pitches. Okay. This one looks about 10 here, and at 10 you're paying about $4. Just by looking at the graph, I can see how much they have to pay. All right, so 10 pitches is about, I'm sorry, let's check that again. This is at 5. So it's about $5. By looking at these two graphs, I can tell which one is proportional automatically just by looking at the point of the origin. By looking at the origin, it's clear that Fun Center is the only graph that passes through 0, 0. So Fun Center is proportional. Since it asks us to explain, I need to write that out in a sentence. My explanation will be Fun Center is proportional because the graph passes through the origin. Now, we can also double check our thinking by looking at the proportion. For $1, you get 4 pitches. Let me show that below here. Okay, so for $1, you can get 4 pitches. For $2, you can get 8 pitches. Since 8 can be reduced, since 2 over 8 can be reduced to 1/4, you will see that it is the same relationship as the first one, so therefore it is proportional. To double check our thinking for Softball Plus, let's start with $4. $4 is 6 pitches. This reduces to 2/3, or $2 for 3 pitches. For $5, you get 10 pitches. This reduces to 1/2. You can see that these two are not proportional. Therefore, Softball Plus is not a proportional relationship. Okay, if you have any questions about example 3, please write them down and we'll go over it in class tomorrow. So in class, be prepared to work on the guided practice with a partner, and then we will work on the independent practice tomorrow in class. I hope you have a great day, and I will see you then. Bye-bye.